Hello and thank you for joining us, and welcome to the Fishing for Data webinar. This is actually our second webinar of the day to enable for as many as possible to attend regardless of the time zone you're in. My name is Gorringe. I'm a physical oceanographer based at the Swedish Meteorological and Hydrological Institute, and I'm also Deputy Coordinator of EMODnet Physics, one of 7 thematic data portals within the European Marine Observation and Data Network. The initial plan was to have a 3-day workshop in Genoa on these dates, that's the 19th to 21st of May. But due to the current COVID-19 pandemic, this has been postponed for next year. Dates still to be decided on later. This webinar is a pitch for that main event and to keep the momentum the announcement of the Genoa workshop created. A lot of my work has been in bringing together diverse marine communities in order to enhance the cooperation, collaboration, and harmonizing data flows, and by this, make a much greater range of marine data discoverable and accessible. I first met Cooper van Vranken, founder and director of Berring Data Collective, at a conference less than a year ago. He introduced me to their activities, linking programs and fleets already collecting marine data, and how they're working on connecting this to the oceanographic community. To me, it was immediately clear that this is something the oceanographic community can really benefit from. Since then, we've been working together to plan and explore the possibilities and opportunities. There are a number of groups who've been working in this direction for some time, but it's early days for us in coordinating these groups and data flows. And in the next 30 minutes or so, we will present progress to date and future plans. We welcome people and groups working in similar initiatives to join us, and anyone listening who collect marine data that they want to share to a bigger community. During the presentation, we'll be conducting a Q&A session using the question window. It's open, so you can start asking questions now if you like. And after the main presentations, a Q&A session will be moderated by Berthe Vastenhoud, Chief Data Officer at Berring Data Collective, who will select a number of questions and our panelists will answer. Joining us for that session are James Manning from NOAA, Michela Martinelli, CNR, Marco Alba, ETT, and Paul Holthus, World Ocean Council. We'll also have a question poll during the session to get a better understanding of our audience and input for possible future webinars. The session is being recorded, and you'll find the recording, presentations, results from the poll, and answers to your questions later in your mailbox. First out is Antonio Novellino, coordinator of EMODnet Physics, to give us an introduction to EMODnet and EMODnet Physics. Antonio is based at ETT in Genoa, and he'll be followed by a presentation by Cooper van Vranken. Last but not least, many thanks to our collaborators and sponsors, World Ocean Council, Copernicus Marine, SeaDataNet, and eMOLT. Antonio and Cooper, I hand it over to you.
Thank you, Patrick, for your kind presentation. Welcome, everybody. So I'm going to give you an overview of the European Marine Observation Data Network, and in particular of the physics thematic lot, under which we are trying to create this new community and create this new and very interesting data sharing. The EMODnet, the European Marine Observation Data Network, is a long-term data initiative created from the European Commission about 10 years ago. The basic goal was to collect data once and use it many times, and reduce the fragmentation of the data sources and the collection research and infrastructure. The data infrastructure was developed towards a stepwise approach in 3 major phases that are ending in this year. But the Commission is already looking towards the next phase that is covering the next decade. And within this umbrella, the European Marine Observation Data Network program, the Commission developed this program by developing thematic projects. So we have one dedicated project for each topic. So we have a project for the bathymetry, one for geology, one for seabed habitats, chemistry, biology, and now we are managing the EMODnet Physics. In parallel, there was also created a transversal system that is the data ingestion facility that is also helping to collect, orphan data and new data from new sources. Going to the EMODnet Physics, the basic goal of EMODnet Physics is to integrate and make available ocean data. And we are covering different time ages, data ages. We go from real time to near real time to historical representative data. And these data are coming from various sources. We are collecting data from fixed platform like mooring buoys or moving platforms like surface load. And we are in charge of different parameters, the ocean physics parameters, temperature and salinity of the water column, sea level, wave winds, currents, and so on. The basic goal was to make available product on ocean physics, and by building on available infrastructure, redistribute and make available the available products and develop new and wider, more complete data collection and products on top of these data collections. As said, as introduced by Patrick, the basic goal was also to make these metadata, data, and products findable, accessible, interoperable, and reusable. And to do so, since we started, we were using and promoting the harmonization and common standards. So going to the data and scope, as just said, the basic goal of EMODnet Physics is to link several sources into a single discovered database. And we are doing this kind of activity by developing smart adapters. And the data flow is designed in collaboration and coordination with the key European integrators and programs, and in particular with the Copernicus Marine Environment and Monitoring Services, and in particular with the Institutac thematic assembly, and the CDataNet networks of National Geographic data centers. But we are also collaborating with other European key infrastructure for data hosting and data collection, like the International Council for Exploration and Seas, and other players, but and we also had an eye on international system and global system like Coriolis, Global Data Assembly Center, but also other communities like South Ocean Observing System or the American Integrated Ocean Observing System or the Australian one. And as we said, we are integrating and making available data and products coming from different platforms that most of the time have a well-defined data flow infrastructure. But for teams or platforms not covered yet, EMODnet Physics start implementing this data flow. And this is the case of the webinar of today. We found these new, innovative, very interesting data sources, and we want to create and harmonize the data flow into the system to make this data available for a wider use and adoption. So from input to products, I said we are developing smart adapters that are collecting and integrating these different sources and federated data. Then we do some checks at the level of metadata. So we feel what is missing by adopting common standards. And for example, we're using the CDataNet P02 vocabularies for the parameters, or the European Directive for Marine Organization to identify the providers and the institutions that are contributing to the data dissemination. Then once we have this data harmonized and ready to dissemination, we make them available via different dissemination channels, because we are making available metadata or the data itself that could be time series or profile or aggregated data with the data map layers and so on. And as said, on top of this data, we are also applying some processing features in order to create new products and make them available via the same channels. Concerning the quality check and quality flag, it depends on the time age of the data. So if we are speaking about near real-time and near real-time data, we have semi-automatic procedures, while if we go for more delayed mode data, then these quality checks are also applied by experts. That could be expert of the platforms, expert of the parameters, or regional expert, which who knows very well the climatology of the place. And in general, we rely on the data sources or the integrators behind us for the quality check and quality flag procedures. And on top of this data flow, we created a web portal which make available all this information. And since we started, we had a look at the global coverage of the data. So just accessing the EMODnet Physics web portal, you can play and have a look at all this data. And for each specific platform, we created a dedicated view. So for example, in case of the Argo, that is, for example, the panel on top left, user can see profiles, while in case of a mooring or a tide gauge, you can see the time series of the data collected. And then we also created a camstone view for other parameters in case of wind or radars, or specific view in case of gridded daytime products. But I really encourage you to play with the web portal and try and use the different links that you have in the presentation that direct you to the different places. To say that on top of these services, we also created the application program interfaces widget in order to facilitate the adoption and the use of all these data and products to also expert users. So by means of this kind of tool, you can easily integrate, for example, a chart in a third-party website, and so make available this data and adopt and use this data. Going to the point of the idea of the webinar of today, we would like to follow and try and have the same success that we had with the HF radar. That is a nice technology that is used to collect information about sea surface currents. In the past, there were several research and development projects that were using or developing the technology. And in 2014, we were asked to start working on this new technology. Then EuroGoose created a task team on that, and together we set up a first coordination event. And the idea of having, the workshop was exactly the same, to have this initial coordination event. In case of the HF radar, in a few weeks, we were in contact with the other global communities, the Americans and the Australian people. In 2015, we had already some data in physics, and in collaboration with other projects, we were developing the quality check and quality flag procedures. We were working on understanding how to integrate this data flow into the Copernicus marine environmental system, and how to guarantee the long-term stewardship of this data in collaboration with SeaDataNet and SeaData Cloud. And since the beginning, we were pushing this activity towards the global integration and use of the data. And in fact, today, we are in 2020, many projects and infrastructure are using this at the global level. The community is keeping working on developing new products on top of this data. And within physics, we had similar activities, a similar success story, also with Ocean Glider, European river data, and marine mammals. Another story that I would like to tell you is about the collaboration we have with the Southern Ocean observing systems, because it's very important and very productive, the collaboration that we established. We started working together several years ago when, from the SUS community, we had a request on trying to identify the possibility to host data, harmonized data flow, and make available this data by means of a map viewer. So we started collaborating because we were really keen to provide this kind of feature, and in turn, we were collecting more data. We were feeding the system with more and new data. And in a few weeks, I would say, we were engaging a very huge community, and nowadays we have a very huge community that is contributing to deliver the data, make available the data for a wider use and adoption. Again, I really encourage you to look at the website following the links. And now we move to the focus of today's webinar, and I give the stage to Cooper.
Thank you very much, Patrick, for the introductions, and Antonio for the background on marine data and the precedent for bringing emerging programs and technologies like ours forward. But also thank you to everyone else who's in attendance. You're an incredibly diverse group and really coming from all over the world, which is something that I'm quite excited about. So let me just share my screen here. So this presentation will be available on video as well as available for download as PDF afterwards. And there are links throughout so that if I don't dig into something in as much detail as you might like, there should be links for you to start looking into that in a little bit more detail. So starting with the background and introductions to fishing gears and how they can collect ocean data, followed by the potential impact to the larger oceanographic community and how this data can supplement existing observation technologies and programs. Next, sensors and data, followed by 2 highlighted programs, the leaders of which are on our panel today, so you can ask them questions at the end during the Q&A session, followed by our contributions to bring this community together and start working on a standardized data flow, and then concluding with future directions that we're all particularly excited about. And so, as you can see from this map, this really is an emerging global network, with orange dots pointing out scientific-led initiatives to collect ocean data with fishing gear, and the green dots are industry-led programs. So you can see in the northeast of the US, eMOLT, Environmental Monitoring on Lobster Traps. This is founded by Jim Manning, one of our panelists. And then in the Adriatic, we've got FOOS, which is the Fishery and Oceanography Observing System, led by Michela Martinelli, another of our panelists. Now, as this webinar announcement went out and really started gaining a lot of traction, we kept having to redo this figure because we were adding more and more points to this map. And that's something that I'm really happy with, as this was one of our key goals of the workshop and now turned webinar, is to bring more programs to the table. So we're confident out of this webinar and future initiatives that more and more programs will come to the table and we'll continue to expand this map. As mentioned before, there are polls mixed in for you, the attendees, throughout. So I think you're about to get the first one of those. And so talking about our background, myself and the core BDC team, we actually come from a fishing industry and fisheries science background, not at all an oceanography background. And how we got interested in this was by what we saw as the future of fisheries science, riding on the coattails of advances in oceanography. And that was all about linking the fish stock and ecosystem health to the ocean conditions as a key building block to ecosystem-based fisheries management. However, the data, especially data at depth going into this science, was problematic. So what we first saw as a path forward where fishermen could catch the data to improve this science, so driving the necessary improvements for fishery science and then eventually management, but from a broader perspective as a way to build a bridge between these communities that traditionally haven't seen eye to eye. But it turns out it's not just us fishy people who are held back by this lack of data. There's a much broader usage group for oceanographic data, which really brings us here today with this oceanography focused presentation. And so the concept, from my perspective, is really quite common sense. As fishing nets go down, fish along the bottom or through the water column and then come back up, sensors can be attached to them to go along for the ride. And so on the downs and back up, the sensors collect profiles of the water column properties. Then as the sensors surface, they can transmit their data to a collection point on the boat and then onto users, all in near real time. And all of this can happen while fishermen go about their normal activities. There's no interruption or very little extra effort on the part of the fishermen. So this presentation is focused on the subsurface data, as this is particularly difficult to collect with other platforms, and fishing activities, I feel, are uniquely well suited to collect this kind of data. Two important distinctions with fishing gear in the way that they affect the type of data that can be produced. And these two classifications are mobile gears and fixed gears. So mobile gears, such as trawling gears, are dragged through the water or along the bottom. This means that the location of the vessel and the sensors attached to the gear changes over time. This makes the produced data analogous to something like a glider track. The second type of fishing gear is fixed gear, which is lowered down to the bottom, fishes for hours to a few days, comes back up, hopefully with fish inside. And that means that the location of this gear doesn't change over time. And so this data is analogous to a more traditional CTD cast with the additional bottom time. And so now that we've seen a little bit about how data collection can be integrated with fishing, now I'm going to talk about why this can be so impactful to the ocean observation community and how this can complement the platforms and systems already in place today. I'm going to do that with a series of maps. This first map shows all of the subsurface data platform collections in 2017 and 2018. And this includes automated and opportunistic platforms. Basically, this means it includes everything except for research vessels. The key takeaway from this map is that most of the points are orange. Orange points are from Argo floats. Argo floats are, you can see, operate mostly in the deep ocean away from the continental shelf. So gridding this data coverage into mean monthly number of observations per grid cell, you can see the same pattern. There's relatively even coverage, but primarily in the deep ocean away from the coast. Now let's look at that same map, but instead we're now looking at fishing activity. The key takeaway here is that the hotspots of fishing activity, for example, around Iceland here, Faroe Islands, Shetland Islands, starting to come into the North Sea here. These hotspots are exactly where on this map the current observations are lacking. So this map over here, with these red points, mean that there are over 100 or more fishing activities that are well suited for integration with ocean data collection. And it's important to note that this color bar over here is 10x the color bar on the current observations. And there are, of course, some exceptions here, such as Northeast Greenland. Northeast Greenland is often covered by sea ice and is also a national park. That means that the sea ice complicates both fishing and ocean observation, but is also a national park, so fishing is prohibited. Now, this pattern that we've seen here with fishing activity concentrated where ocean data is lacking isn't limited to the North Atlantic. In fact, it's repeated in shelf seas and coastal waters around most of the world. So I'll do one more example, and I like Alaska because it's a very clear pattern. So again, we've got primarily Argo observations in orange here, and then on the shelf, much fewer observations. We've got a shallow water Argo deployment here, a few buoys in green here, and then these pink points, these are marine mammals with sensors attached to their heads or backs. So that's kind of a fun one. Now let's look at the gridded versions of these maps. And again, that same pattern can be clearly seen where the fishing activity is concentrated exactly where the ocean observation is not. Now, it's not just that fishing activity takes place today where data is lacking, but actually it's especially important to get data in these regions. And that's for two key reasons. The first is that the shelf and coastal regions are subjected to complex and more rapidly changing ocean conditions than the deep open ocean. That means that models need more data to be accurate. The second reason is that the coastal regions are where the majority of maritime activity takes place, both industry and recreation, far beyond commercial fishing. That means that these regions are where model and forecast accuracy matters most to stakeholders as well as maritime industries. One more key piece to this puzzle is the sensors. Sensors need to be compact, robust, and with automatic wireless connectivity so that they can send the data to a collection point without interrupting the flow of work on the vessel. So I'm going to pause the presentation here momentarily to show two example sensors. So here, this is an NKE CTD. So this collects temperature, salinity down to 300 meters depth. You can see it's reasonably compact, pretty small sensor. And another key feature of this is that this uses Wi-Fi connectivity. So it's well suited to medium and large vessels because it can transmit the data over a little bit longer range than other wireless connections. And this is medium high resolution, so pretty good data quality out of this actually, which is surprising for these very small and compact sensors. In addition, the NKEs come with these very rugged protective housings. You can see these two pieces here that stand up well to the rigors of fishing and then have these nice attachment points to integrate with fishing gear. And this one you can see has been beat up a little bit. This is fished for 9 months in the Bering Sea, Aleutian Islands. So very rough volcanic bottom on a bottom trawl gear, and then after that fished in the Baltic. However, still fully functional. And the second example I want to show is this much smaller ZebraTech. This is a prototype sensor developed in conjunction with the Moana project in New Zealand. A key distinction with this one is that this is temperature and depth, no salinity like the NKE I just mentioned, lower resolution data, and also uses Bluetooth rather than Wi-Fi to transmit the data. Bluetooth uses less battery, but can't transmit over as long distances. And so I'm going to start up my presentation again here. The key takeaway to that is that different sensors for different applications, both in terms of data requirements. If you require very, very high resolution data, then that ZebraTech probably won't work for you. But also from the way that the fishing gear is set up. The ZebraTech is probably better suited to very small scale fishing gear where the larger NKE might get more in the way. So down in the bottom, I've got some links to the two sensors I've just discussed, as well as a link to Lowell instrumentation, which are the sensors used by the eMOLT program, one of our focus groups. Now, two data examples. Both of these data examples are collected with an NKE CTD. So that was the first sensor I showed. And this first figure in the lower left, this is a series of profiles collected over about 2 weeks off of Denmark. And you can see very clearly in the water column warming. So in the spring of 2019, the water column warming, as well as a very strong salinity gradient. Now, this next visualization is how it shows up in the EMODnet Physics data portal. And this is one trawl tow off the coast of southern Norway. So you can see the descent down, the track along the bottom, and then the profiling back up, both for temperature and salinity. And then below, the more traditional oceanographic perspective with the TS profiles. It's also important to note the metadata and links that are in that side panel there. So this is data that we've collected, but programs that we're working with as well have their logos and links directly all through there. And Marco Alba is one of our panelists, and he's the architect of all of this, as well as this information in this portal. So feel free to ask him any questions about that during the Q&A session. Now, our first example program, eMOLT, as far as I know, this is the very first program to do this, started in 2001. The acronym Environmental Monitoring on Lobster Traps has now been expanded and now works with trawlers, scallop dredges, long lines, etc. eMOLT has approximately 40 vessels active that produce data from thousands of hauls per year. You can see in this blue chart the number of hauls increasing per year and is now about 3,500 hauls per year. And below that, a map, the distribution of hauls, mostly concentrated around Massachusetts, but then spanning a very long range along the US East Coast. And interestingly, really hugging that shelf break zone right there. eMOLT also collaborates regionally with other programs, including the Northeast Cooperative Research Program Study Fleet, an industry organization, as well as an organization up in Canada. To me, the standout thing about eMOLT and what Jim Manning and Jim Manning's work is the dialogue and feedback that's cultivated between the captains participating and the scientific community. And I'm hoping that there are several captains actually on this webinar right now. So thank you all very much for your work on this. And then down in the bottom right, we've got 3 papers about eMOLT, and that middle one and especially speaks to the benefits of that stakeholder involvement to the scientific community. Second example program, FOOS, so the Fishery and Oceanography Observing System. This is started by CNR, so the National Research Council of Italy, in 2003, so not long after eMOLT. Its original form was the FOOS, the Fishery Observing System, and then in 2013 it was upgraded to the full FOOS system, and Michela Martinelli was a key leader in that process. FOOS has collected thousands of profiles, primarily from purse-seiners and trawlers in the Adriatic. The thing to note about FOOS is it's more of a complete system than many of the other programs. So it also includes kind of an electronic logbook for catch data and that kind of thing. So all of these data types are linked together. In addition, FOOS has been instrumental in experimentation and development of many different sensor types, beyond simple physical parameters to biogeochemical and things like that, system validation and system design, as well as the establishment of best practices. And you can see the links on the right here. There's quite a wide assortment there, so I recommend taking a look at some of these. There's fishery science papers in here. There are oceanography assimilation experiments, there are data sets, there's best practice documentation. There's quite a lot there. Now, ocean modeling use cases. We're hoping to have more of these in the future, and this is a core goal of this and future initiatives. Right now, we don't have too many. The first is a statement from Dr. Yun Shi from the Danish Met Institute, speaking about a little bit of our data from Greenland, and not just to the quality of the data, but from my perspective, more importantly, to the availability of and the potential to have data where it's currently lacking. The second is one of these papers from Michela and her colleagues at FOOS, and this is an assimilation experiment with the data in the Adriatic. And stay tuned because there should be a second paper coming in not too long with the more recent data set. That recent data set is linked to on the previous page. And the eMOLT data goes to regional ocean modelers, but is also used in the lobster stock assessment. And to me, this is a real testament to the multidisciplinarity of this data. The final example from our colleagues in Japan, they collect CTD as well as ADCP, so acoustic Doppler current profiler data, and then this data is assimilated into a local ocean forecast. And the fishermen actually use this data to inform their fishing decisions. And this link is a very nice news story that came out last week or maybe the week before. It's about 3 minutes and quite a nice little piece. So I take a look at that. So now, what are we at Berring Data Collective doing? So in addition to collecting data on vessels that we're working with independently, I feel our biggest impact is working to bring this community together and working to create a centralized data handling system. And we're building this all around the FAIR data standards. So FAIR stands for findable, accessible, interoperable, and reusable. But we're doing this also with the added by also meeting the needs of stakeholders with confidentiality that doesn't compromise data quality for ocean data users. And I really feel that this is necessary for scaling this up and bringing everyone to the table. So we're aggregating data from both science and industry streams into this common relational database with quality control, metadata standards, and then passing it on via flexible mechanisms such as ERDAP to data users such as EMODnet. Programs that work with us and distribute their data have added exposure and impact from their data, but also have full traceability back to them as the data originators. On the flip side, the science industry programs have the needed confidentiality and protection needed to participate. And we're doing this all in a way to maximize the data interoperability and reusability across different disciplines. And the key to this is the proper metadata standards to interact with the different scientific and industry fields. One final kind of technical tidbit here is how we're doing this is really with our core unique tow ID structure. So that means that data can be sent at any time. So that really makes this whole process more cost effective. So we can send data in real time, days, or even months later, depending on the time sensitivity, as well as being, as not interrupting the flow of work on the fishing vessel. And so our goal is really to help you. If you're a fishing industry and fishery science and would like to start producing data, we'd love to talk to you about that and different sensor options, as well as the data collection opportunities with the fishing gears that you work with. If you are collecting data, our goal is to help you put this data to work and increase the impact of that data. And if you're an oceanographer, our goal is to get you to use this data and increase the accuracy of your models where it matters most for forecast users. And so shown here with myself is the core team in Denmark, as well as in Brussels. But we would not be here without the help and guidance from many, many others, as well as the on-call, larger, extended Berring Data Collective team. So I owe many thanks to many of you. Many of you are in the audience, and we look forward to working with more of you in the future. So now, as I begin to wrap up my talk, I want to discuss some exciting opportunities beyond subsurface data. So we've been focused on this subsurface physical data. However, fishing vessels are not limited to just collecting this physical data. Both with additional sensors on the net and additional sensors placed in other locations on fishing vessels, they are able to collect additional essential ocean variables as well as essential climate variables. And a key part of this is that these variables are co-located. This means that by collecting them from the same point, the same platform, there's added value because scientists are able to link what's happening beneath the surface of the ocean with the surface of the ocean with the atmosphere. And this co-location is key for coupled ocean and atmosphere models, as well as coupled biological and physical models. And this is the multidisciplinary modeling and science that we really strive to support. So to wrap up, we're working as hard as we can to facilitate this because we feel this can be so mutually beneficial with improvements compounding, not just for the fishing industry or oceanography, but to the broader blue economy, the health of our oceans, and the future climate. This core concept is repeatable and scalable for most coastal waters around the world. And in addition, this data is reusable in multiple disciplines. Furthermore, integration with these existing vessels means that this method of ocean observation can be cost effective. And so this is something that I hope may have the potential to, in a sense, democratize ocean observation. And this is both on an individual basis by engaging citizen scientists, but more broadly on an international basis by making ocean observation more accessible to nations with less resources that they're able to dedicate towards expensive ocean observation and monitoring. However, as has happened with this emerging network, a bottom-up approach is essential. With local partners, programs, and fleets, the only way this will be possible to scale. And so we hope and look forward to working with many of you in the future. All right, so that's the end of my talk. Thank you all very much from myself, the rest of the Berring Data Collective team, as well as EMODnet Physics. If you've got any questions regarding this webinar, please feel free to reach out to this email here. This will all be downloadable after, as well as a video replay. And so now I'm going to hand off to Berthe Vastenhoud, the co-founder of Berring Data Collective, to lead the question and answer session.
Thank you very much, Cooper, for your very interesting presentation, and hello, everyone. So before starting the Q&A session, we have one last poll, which I will launch now regarding possible future webinars. And as mentioned before, for the Q&A session now, we have a few additional panelists that I would like to introduce. So first of all, we have Marco Alba, who is the lead developer and data manager at EMODnet Physics. Then, as the principal of integrating sensors with vessels is more common in other maritime industries, such as shipping traffic. We're very happy to have Paul Holthus, the president of the World Ocean Council, on our panel. And WOC runs the Smart Ocean, Smart Industries program. This aims at increasing the impact of Ships of Opportunity programs by leveraging industry participation. Then we have Jim Manning on our panel, who is the founder of the eMOLT program, previously presented by Cooper, as well as he's also involved in a variety of other ocean citizen science projects. And last but not least, we have Michela Martinelli from the Italian FOOS program on our panel, who's also done a lot of work on sensor validation and best practice documentation. And then, of course, Antonio, Patrick, and Cooper are also still available for questions. So I'll be moderating this session, and may I remind you that you can keep on asking questions in the Q&A window down below, and that you can also comment on existing questions and upvote questions that you find relevant. So let's start with the first question, which is a question that I find very relevant and interesting, from Julia Calderwood, who is asking what benefits the fishermen get from putting sensors on their fishing gears, and whether there are particular incentives from them doing this. So I think this is a question for Jim and Michela first. How do you do that in your programs? How does it work?
Yeah, I've found that nearly all fishermen I've talked to are convinced that temperature has something to do with their day-to-day changes in catch, and so they are just curious. They're interested in seeing the variability of the bottom temperature, which often most of the year degrees different than what they measure at the surface. So it's not a problem finding fishermen willing to get set up with the equipment.
Okay, and Michela, how does it work in Italy?
Yeah, well, here in the Mediterranean, the situation is a bit different because not all fishermen are willing to participate to such kind of programs, but we were lucky with some of them volunteering to participate. And we, other fishermen, we made some agreements. Sometimes we had to pay for the data, sometimes the agreement was different, but somehow we managed that. I should say that actually here the situation is quite more difficult because vessels are sometimes smaller, and of course fishermen are not so willing in the Mediterranean to exchange information about where they go to fish and everything like this. So in every part of the world, the situation could be different, and this has to be taken in account when planning a program like this.
Interesting. Okay, thank you. And Cooper, maybe do you have anything to add? How does it work at Berring Data Collective?
Yes, I can add to that. You know, we've talked to quite a large range of very small scale to, you know, massive factory trawlers, and unfortunately, the answer to this, I feel, is really, it's complicated. Fishermen are interested for different reasons. You know, for these very large scale ones, it's really the data analytics components and the fisheries management implications of collecting this data. And then for the smaller scale guys, it's very different. But oftentimes there's the ecosystem and the climate change motive. You know, one guy from my hometown, you know, I said, hey, you know, can I come out on your boat and try this thing out? And he's like, no, we don't have people. And then I said, no, I don't want to come out there and just to take pictures. I want to measure the temperature and look at the catch and things like that. And he said, Cooper, okay, you have to come out. We're seeing changes under there, and nobody's looking at this. So this is really important. And to me, that was pretty exciting.
Interesting. Yes, and Paul, how does this, well, this is a question more from me, but how does this work in other industries?
So we've got work going on through the World Ocean Council Smart Ocean Smart Industries program to really create a platform that provides a place for the fishing industry to engage with other industries that are involved in data collection and voluntary observation programs. And as Cooper pointed out, it's not just about oceanographic data, but it's also about weather and climate data. And so the other sectors, and especially as you can imagine, the shipping industry has long been engaged in providing weather data back to authorities. And in fact, a lot of what we know about how weather patterns work and the forecasts that we have now come from the immense amount of data that comes from the shipping industry and the regular reporting. The overall, the work through largely organized through the Intergovernmental Oceanographic Commission, with whom we have a partnership agreement, and the World Meteorological Organization, with whom we also have a partnership agreement. They have been looking to expand the role of industry involvement in data collection from all the sectors. And so this is what we're working to do through the Smart Ocean, Smart Industries program. And so the shipping industry, for example, then is interested to understand what the opportunities are to help fill some of the gaps, as we've talked about this evening, by utilizing fishing fleets. Likewise, the fishing industry can be complementary, or its efforts can be complemented by what's going on in the shipping industry, offshore renewables, offshore extractive industries, etc. And so really creating this this broader interrelationship between the industries on voluntary data collection really, I think, creates some great opportunities for synergies, for economies of scale, for partnerships in sensor development that reduces the cost so that we've got more efficient, energy efficient, more easily installed sensors for the fishing fleets and for other industries. So this work that is being talked about this evening, or sorry, my evening, today, and in the proposed workshop, I think to really move forward with organizing the fishing industry can really play a major role in helping overall accelerate and move forward with data collection from a variety of industries.
Okay, thank you, that's clear. Next question from Martin Pastors, whether we're already working with existing sensors on fishing gear, such as SIMRAD sensors. Cooper, that might be something that you can answer.
So I've been looking through here and seeing a lot of sensor related questions. So I'll try and knock off quite a few of these at the same go here. So thanks Martin. Yes, this there have been a few different organizations who have worked with this, and actually we just found a very exciting one that's, I think, done more work than anybody, not using SIMRAD but using Marport. A few different industry bodies have used Marport. I've collected a little bit of SIMRAD. We need more work on this and more analysis. Right now, the data, the bottom data from these existing sensors looks good, but there's usually some problems with the measurement response time for the profiling. So that's existing sensors, but I'm hoping that we can work with these sensor companies to increase the resolution of those sensors and the response time. So there's a few different things about the depth of sensors. So the NKE CTD is 300 meters, but there are NKE options for 1,000 meters and 6,000 meters. So there are different options there, as well as the ZebraTech. That one I showed actually goes to 1,000 meters as well. Oxygen sensors. Yes, there are a few different options there. NKE has a new version coming out shortly, or out now. I'm not exactly sure. I haven't tried it out yet. Also, Lowell Instrumentation is developing something for use on the West Coast with crab pots.
So how do you see this program in the future? Do you see this as have every fishing vessel integrated with have a sensor, or is it more interesting to have a small subset per region, but more spread over the world? What's your idea?
Well, the more the better.
Yeah, we start small and then we build.
No, actually, I mean, if we can really engage the community and work together in order to make available this data massively in terms of time and spatial coverage, a lot of other communities would benefit from that. And for example, if we think about the benefit that you can have in order to feed the model forecast, and then you give back better services to the people that are contributing to this data collection. So the more, the better.
Okay.
Maybe Berthe, I'll jump in on that as well.
Yes, thank you, Paul.
Yeah, Paul Holthus from the World Ocean Council to put that question about scale and the diversity of components of the fishing industry, to take it to a broader scope, to think about the scale and diversity of other kinds of vessels and platforms that are in the ocean. And so when we collectively think about the opportunities to scale up and replicate the collection of data by hosting or deploying sensors, there are, of course, the other industries that are sharing the ocean with the fishing industry. And these other sectors, and in fact, shipping industry has been involved in data collection for both oceanographic and weather and climate data for quite a long time through a variety of programs. And so at the World Ocean Council, we worked to develop that scaling and replication by having a global multi-industry platform, which can benefit from the experience of and efforts of the fishing industry, but also the fishing industry in its efforts and interests to scale up and further expand the data collection efforts, can benefit from what's going on in other sectors. And so, to be very practical and to give some examples of this in terms of the sensor technology development, if essentially we have a bigger market that's beyond the fishing industry, to include tourism, for example, vessels that are of similar size to fishing vessels, the expedition tourism vessels, and then look even more broadly into the many other kinds of vessels operating. That creates a market for those that are developing the sensors that would help create efficiencies, standardization, and reduce costs, for example, in the sensors, and that will benefit the fishing industry. And so it really, this scaling can really look at a whole global network of multi-industry applications of effort to data collection. Thanks.
Thank you, Paul. Yes, and related to that, there is another question about the use of these types of sensors more for people that use the ocean recreationally, such as sailing boats. I'm also thinking about, for example, scuba divers. Has there any work been done related to that?
Well, we have been interacting quite a bit with the recreational boating industry. And so there's quite a bit of effort there in real citizen science level of data collection, and there's a variety of programs that have been working on that and looking at how to interface that with the commercial operators. And again, that this creates a bigger market for the technology development and a bigger pool of data that can be collected from vessels. And so there's been quite a bit of interest and development along those lines. One of the particular topics that has been really harnessing the opportunities with the recreational vessels is the efforts to collect bathymetric data, for example. And so there's and then we at the World Ocean Council, we are partners with the International Hydrographic Organization and a supporter of the Seabed 2030 campaign. And so there's a particular piece there that's focused on recreational vessels. You mentioned scuba divers as well, and there's certainly the marine tourism, marine ecotourism vessels are also a great opportunity for data collection. And then beyond the scope of, I think, what we're discussing here, of course, divers that are actually in the water, there are entire citizen science programs there for them collecting in-water data through personal observations as well.
Okay,
just
thank you, Paul.
just one small little addition to that, because
Yes.
there's a program in the Mediterranean called EMODnet, and EMODnet have scuba divers who deploy mini loggers that then measure temperature. It's really nice, and we're collaborating with them in EMODnet, and we're already feeding data from these mini loggers. Many of them, some of them have been there for up to 20 years. Very nice initiative.
Interesting. Then I see also a lot of questions coming in more on the practical side of the sensors used. So calibration times, cost price, other brands and models of loggers. Michela, I think you've done quite some work on that.
Yes, of course. We've been working with two different kind of probes because we started with the first version of our observing system using mini loggers from Starhoddy, and then when we changed it to FOOS, we moved to Enki probes, and we did some evaluation of the two probes through the work with CNR and as well our colleagues from IRBIM. We worked together jointly in the framework of the European Jericho Next, and Nexus projects to develop these sensors from Enki. We also try to start some best practice procedure, to draft some best practice procedure for the use of this kind of sensors. And there are some few documents that are as well, which is linked in the presentation. What I can just suggest before somebody is very interested to move to these papers. There are two important things to take in account while choosing a sensor to be mounted on a fishing gear. It is, of course, the operational conditions. So it depends a lot on the fishing gear that you are using, and the sensor that you want to choose depends as well on the fishing gear and on your requirement from the oceanographic point of view. And we strongly suggest also to make some trials with the sensors before using it on the fishing gear, compare it with the traditional oceanographic tools if you are used to work with it, and define offsets that will be able to you when you will handle your data, to use together with the data, of course. And from time to time, it's a good idea to repeat these procedures, but maybe I went too technical on this part. Always about the sensors, we are talking about, until now, about CTD-like sensors, but there are other probes in development. Some of those has already been developed for oxygen and chlorophyll, and there are new developments going on. And we are participating as well in these developments together with the Enki company, but as Cooper suggested, there are other companies as well working on this side, so maybe Cooper can add something.
Cooper, do you have something?
On sensors in general.
Yes, sensors in general, I won't, and Michela did that very well, so yes, different options. I want to add two things to that. I think really, technically, more what we're missing is a more modular deck system and a system for that, and that's very challenging on a fishing vessel. Fishing vessels, the layout, even within the same fleet, will be very, very different depending on how each captain does. So modularity of those systems, it can be pretty tricky. The other thing, on a more positive note, is that there are calibration opportunities for these sensors since the fishing vessels come into port in regular frequency. And that's actually pretty unique compared to other ocean observation platforms, which are very, very expensive to go out and bring them back in for calibration, or just can never be calibrated again.
Going to take one last question, which is whether we're collecting or accepting also data from other small scale experiments using data loggers from coastal areas. That's, I think, more an eMODnet question.
We're totally we say yes. That's what we say. Any data, please let us know, and we're very, very interested to take anything on board.
Okay, thank you, Patrick. And with that, I would like to wrap up this session and thank the panelists and the presenters for the interesting program today. And of course, the audience for attending. We will be in touch with more information with the PDF version of the presentation, with the recording links. And in the meantime, please do not hesitate to contact us if we can help you with anything through the ffd@emodnetphysics.eu website. And Patrick, you also wanted to?
Oh, just saying that we will also answer all the questions. And
yes,
we'll make them available, all the answers as well,
yeah,
together with the links to the webinar and so on.
Yes.
Yes.
Okay. Thank you very much, and hope to see you soon.
Thank you.
Thanks, everybody.
Thank you.
Bye.
Thank you, everybody.
Bye bye.
Thank you.
Thank you.